Hi, I'm Andrew Armstrong and welcome to the back office show. Well, in fact, the Teardown Lab. It's pretty much all the Teardown Lab these days. Quick one for you, just a quick update. The video is not going to be a quick one, but this is the quick update in the main video. I bought a bunch of these ELM327 interfaces, which are for OBD2, and I'm using them for the enclosures and the connector. It's cheaper for me to buy them this way and then bin them, basically. Well, I'm not actually binning them, though. I'm keeping the gubbins. So this is the gubbins. It's a USB to ODB. Sorry, OBD. I keep getting that from my brain on that. That's a car interface. I've got the pinouts here, by the way. So this is pin 1. Yes, this is pin 1 on these, and it goes from 1 to 8. And pin 1 connects to OBD 16, 2 to 8, 3 to 15, 5 to 14, 6 to 4, 7 to 2, and 8 to 10. There's a lot there because I think this supports more than CAN. This does the K line and some of the other ones. I'm going to be probably putting these on my back office show shop website just to sell them off to get a bit of money back to the channel. So I'll put them on there. And I know you're going to be saying, why would I want that? Because it doesn't have that. These are really great, by the way, for just hard wiring. So if you want to get into your car, get to the back of the connector like that and just hardwire these into it with a bit of some fly leads. You can have a permanent USB setup in your car to when you want to do diagnostics. It's quite useful. It does come with a CD of hooky software. I don't know how many of those CDs I have lying around, so I kind of bin them. But if I do have any, I'll supply them with that too. They're basically, I don't know, either cracked or abandonware or whatever version software to do in-car diagnostics. But I'll include them, and you can destroy them if you feel you don't want to use that. Yeah, because that aside, you know, just I do have my own, based on my own Booby Cortex hardware, and this is an early version of that, and that's what that is. So I have a job to do, though. I'm quite busy with actual real work, and that's consuming the bulk of my time. And I thought it's sort of preventing me from making my regular videos, although I'm still making the videos regularly. You'll notice that the content isn't as deep as it would usually be. I've decided to just sort of do this as a kind of more of a vlog as I'm doing a bit of work. So I've basically got a diagram here, which is my wiring that I'm doing. So I've built a commercial product, which is a 5-channel CAN bus analyzer, and it uses these rather snazzy M-series connectors. I can't remember who they are originally designed by, Tyco or something like that, but they're kind of slightly industrialized waterproof military type thing. So it's a nice bit of proper test equipment, and it does 5 CAN bus channels at once, and of course that means 5 CAN bus leads. Now you're looking at these leads and you're going, how long are those leads, Andrew? Yeah, they're pretty long. I think they're about 3 meters each. And then your next question is, you're saying to me, Andrew, CAN bus, the maximum drop at whatever frequency you're using, and I'm going to guess I'm going to be using, according to this spec, 500 kilohertz, is going to be something like, I don't know, 40 centimeters or 30 centimeters, something tiny. And you would be absolutely 100% right in saying that. That is indeed the maximum drop of a CAN bus, and that will cause big problems. However, these are going to be connected to the manufacturer specific onboard diagnostic, just cutting that, onboard diagnostic port on a vehicle, and it has multiple CAN buses, so that's why I've got 2 here. I've actually got 3 to go in one and 2 to go in the other. So I'm going to be treating these aren't, because they're going into a gateway, I presume. I'm going to presume they're going into a gateway, and then that way they're not considered as a node drop. They'll be considered as a, well, just a node-to-node termination. So I think it's going to be okay. So I'm going to go with that. And if it doesn't work out, it doesn't matter. I can hack these down, make them nice and short, and service them in the field, basically resolder it. I'm bringing all the equipment with me for that. So I'm just stripping these out. Yeah, so with regards to the sort of other videos, just my life, and I know some people are interested in that and some people aren't, but yeah, I've been really poorly basically recently, and when I get poorly I stop doing my exercises and I start eating and feeling miserable, as most people do, to be honest with you, and that's sort of consuming my time. So I'd not really been in the mood to making massive amounts of videos, or haven't really been doing anything interesting enough to video. I did a couple of videos whilst ill, and I found that they were basically uneditable. So there was no redeeming work in that. I could spend hours and hours just editing those videos, or I thought, well, I could cover those subjects again in the future and just record them properly. So it's quite interesting, this recording video lark. It doesn't seem like much effort, does it? You would think I just turn on a camera above my hands and start talking, which is what I normally do, and but it's not. You can even screw that up. So there is a point where there'll be so many cuts and jump cuts and things like that, you just go, nah, it's just not worth it. And the other thing that's been weird, as part of this sort of weird cold, it's just a cold, but it's just malingering, you know. Hey kids, when you get a bit older, your cold might last longer. And I consider myself to be in reasonably good health. You know, I think I'm pretty fit in terms of, just attractiveness, obviously, but in terms of actual general health. So it's so funny that something like a cold can sort of really hit you that hard. But I don't think it's doing it now, but these look pretty steady. Every now and then I get a bit twitchy like that. You see my hands start going probably about that level of twitchiness. So when you're holding a soldering iron, you know, right at the tip of the soldering iron, if the camera will even focus on that, it's pretty good now. It's pretty good now, but you can see it was a bit like that, and I was just like, nah, that's not going to work out for me. So yeah, it's got a bit much, so much so actually. Thanks to some friends online, I've even sent some bits and pieces out. So thanks Brian. Thanks Brian for your help. He's doing a little job to help me out, and that's really useful. So in terms of this thing I'm doing now, let me just tell you a little bit more about it. So it's a multi-channel CAN bus reader, so that lets you not just reader, it interfaces. You can interface it to your vehicle, and it also mounts itself, if you're using it in Linux, as a network device, so you can hook that into the normal network architecture of Linux, which is cool. So you can start using Wireshark and all of those other things to do analysis on the CAN bus. And I've written a really cool stack. So basically I've designed all of the module and the hardware as well. So the driver for Linux connects to the hardware and interrogates all of the units, and it works out basically how many CAN channels you've got. So I've designed it so you can have as many CAN channels as you want. So this particular one's got 5, but you could have 50 if you really wanted. And I've kind of cheated for internal bus interfaces. I've used USB, which is awesome, because if you think of USB 2 or USB 3, this is USB 2 in this case, you've got hundreds of megabits of bandwidth there, whereas CAN bus maximum is like 1 megabit right now. There are faster standards for it coming out, but they're not so popular right now, so I'm not worrying about that. But yeah, so you've basically got enough to support many channels. There we go, gotcha. That was a bit tenacious, that one. Yes, you can just basically hook this up to a vehicle, and many modern vehicles have more than one CAN bus. If you can find a CAN bus on your vehicle, by the way, remember, not all the interfaces on the onboard diagnostics slot are CAN, but fortunately if you're in America, I think since 2009 they've had to be, so all of the gateway on your American vehicles will be CAN bus. And in this case, the manufacturer ever so nicely has put all of the sort of internal CAN buses out onto the diagnostic connector too. So I suspect that's because when you've got these modern electrical vehicles, they have differing requirements, probably in terms of their testing and servicing. So they're still a bit of a wild west at the moment. So I think the manufacturer's just gone belt and braces and made it simpler for their service people by including all they can, and that's what we've got here. Now I'm basically stripping all the wires in these connectors and ready to tin them, but I don't actually need all of them. So CAN bus is a differential signal, so you just have a high and a low. The low is basically the mirror image of the high, and that way, regardless of what's going on with the sort of power transients, they'll all look the same. I'm just going to get the box over here to fetch it. I'm fetching the CAN bus box, and probably going to cover up the company name there, but yes, so you can see it. It's got those connectors there, and you can see the back here. I've got my pinouts quite nicely, probably lasered out there, but that's telling me the pinouts. Like I need that because I want to connect these up, and I decided to make sure all of the labelling was laser cut into the boxes. So what you can do, anyway, let's get back to it. What you can do is, by the way, I just only need blue, brown and black. Blue, brown, those three colours on each wire. Is that you can record in great detail every single bit of communication your vehicle is making. And not only can you record it, you can actually analyse it. So you can actually see what patterns there are, in the data stream. So, for example, every time you hit the brake, you might see not only just a brake light thing flashing, you might see something that alerts the engine that the brakes are being hit, so that the engine itself is making some decisions. Or if you've got an electric car, it might be the regenerative braking system might status might change in that, because it's going to be updating the center console of what's going on in the vehicle. So you get all this good stuff. So with it, you can actually analyze the CAN traffic, and you can actually reverse engineer, if you want to, what's going on in your vehicle. And you're like, well, why would I want to do that? Well, if you're messing around, and you've got to be a little bit careful if you're messing around with vehicle systems, because they do control everything. You can do things like, on the little screens that tell you stuff, like tell you your radio station. Those are often done by CAN bus, so you can maybe put your own messages on there. Or when you do the volume up and down, you might want to be able to analyse what's going on with that, so that you can actually do your own volume up and down. So it does seem a bit trivial. Brown, blue. Sorry, I keep getting confused here. But there's loads of scenarios. So if you have one of the Booby Cortex boards, for example, and it's got the CAN module fitted, and I kind of think I'm going to do a production run of those shortly, and I'm trying to decide, do I fit CAN to all of them? It's a bit of an extra cost, and it will put up the cost, but it's just more convenient to have them pre-fitted or not. You can have things sitting in your vehicle, and you can have them do things based on what it reads too. So you can have, when your car hits a certain RPM, it can flash a light, or when you do something, reach a certain speed, it can activate something else. So you can use it to trigger outside systems. Now, if you're really trying to be hacky, we did a test, and you'll know Jared Rebo, multi-rotor guy, on his car for a bit of fun. And you could actually alter the reading on the speedometer, not the speedometer, sorry, the rev counter. So you could see one of the management systems, the engine management system, was outputting revs, RPM, and that was clearly being read by the center console. And sorry, I say center console, like the dashboard binnacle. And if you emulated that signal, so you transmitted your own packets with that in it, and you had to transmit it quite regularly because it was quite a frequent communication, and I guess you want it to go frequent enough that you're drowning out the original signal, you can actually change the revs. So you could see the rev needle moving. So you were saying, I want to set it to 1,000 RPM when it was sort of idling at 600, for example. I'm not sure on a use case of that. Apart from, that's quite neat if you want to use standard parts of cars in your own sort of project. So if you're making a kit car and you want to use the dashboard from something, that's definitely a nice option for you. Right, so we've got all of our things tinned. So we've got our two onboard diagnostic connectors here, and the first one contains three. It contains 3 CAN buses. So we've got channel 1s, 2 and 3. Now the problem is, of course, one of the channels is a single wire CAN, and it's at the rather annoying speed of 33.3k. So I'm not quite sure how we're going to be handling that bad boy. But CAN high is brown. So if you're doing single wire CAN, you just would only connect the CAN high. So that's fine. And that's located on onboard diagnostic pin 1, which is that one in that side. So it's that one there. We can zoom in, we'll have a little look-see. So what we're going to do then is solder that wire right there. And I'm just going to touch this up. So this is, as I say, connected to one of those old ELM modules. I'm going to connect straight to the pins because it's hard to determine exactly what pin. Not all the pins are connected through, basically. So manufacturers have to use certain pins on these connectors for onboard diagnostics, for example, and you'll find, like this case, some of them have, there's some manufacturer sort of specific pins, so there's a few pins reserved for the manufacturers, and sometimes they put their own just buses, sometimes they're just simple outputs, and in this case the manufacturers opted to put CAN data on it, and that's very convenient for us because it means we can access those CANs. I'm just going to hold that there, get that there too. And we've noticed more and more in vehicles the use of gateways, and the reason they're sort of using gateways is because, of course, if you've got, say, a system that updates the Wi-Fi via Wi-Fi, you don't want that to be able to talk to the main controller, say, in your engine, because that way you could have a virus that could come in via your radio or something and then spam out your car. So they're becoming really quite cautious of that, and I'm really rather pleased they are. Now I've got a decision here about the grounds. Do I want to connect the grounds or leave them floating? Because CAN's a differential signal, you don't need to connect the grounds. In fact, there's sort of several good reasons why you might not want to connect the grounds. So that's something I'm going to decide in a little while, but in the meantime, let's see. The next ones, network 2 is on pins 6 and 14. So that's pins 1, so 1, 2, 3, 4, 5, 6. Pin 6 will be here, and that will be a CAN high. I think that might be the actual standard CAN, which would be coming in on pin 6. It rings a bell. I mean, I do forget quite a lot of these things. Just have to always look them up when I'm in the vehicle. And the opposite will be pin 14. Yes, it would be. So that, I think, is the standard. Let's get that in there. Gone deadly quiet now, just focusing on that one. So that's 2 in. And we got one more, which should be channel 3. Yes, that one is indeed channel 3. And channel 3 is going to go to pins 12 and 13. Pins 12 and 13, 12 being the high, so 12 being the brown. So those two side by side, so they're not opposites in this case. Boom. And the other thing you can do with CAN, of course, is to diagnose your vehicle. I mean, that's the most basic use case. And you can buy really lots of cheap adapters nowadays online that can do that. And you have to buy certain manufacturer specific ones though if you want to do particularly fancy things, because again they don't have particular standards between them all, but the ECUs tend to be made by standard companies, standard manufacturers are producing those modules. So that's the module going to go in there, and I'm going to hook up those, decide what I'm going to do with those grounds at some point, so I'm just going to test fit that. Nice. That looks pretty good to me. So let's do the next one. So we've got channel 4 and channel 5. So this is the channel 4 one. Yep, so the standard units, inside the cars are probably made by people like Bosch or Siemens, and they're going to control your, if fuel injection or braking system or turbos or anything. To be honest with you, it could be anything. So they all have particular types of programming for their sort of firmwares and memories and things like that, and you'd need to speak to an automotive electrical system designer to really get the current status of all of those things, because they do vary somewhat. Interesting enough, by the way, this one is all using the custom pins. It doesn't use the standard CAN pins at all. So we've got a high on pin 3. Channel 4 is high on pin 3. Okay. And it's a low on pin 11. Which again, that's easy for us to hook up. Low on pin 11. So despite the standard modules being used in the car, they have to program them and communicate them via the gateways in the vehicles, and then the gateways obviously can have their own standards. So a good example is a company like Tesla, which does, I think, most of its updates and everything over the air. They're quite famous for that, being able to sort of switch on and off things and give you extra range. They recently did that. They sort of revealed that the cars can go further than they let on. So you have to pay more money for the more mileage, basically, by giving people during the time of a natural disaster a few extra miles for free. There was a little bit of an uproar about that, but let's be fair to Tesla. If you run the batteries at their maximum capacities and things like that, there could potentially be a service issue, because the batteries won't last as long, and then that way you could use that to justify why you charge more. If you pay more for the premium distance, you're getting a better service. You're getting batteries that might fail more, and they'll have to fix them more. So there we go, that's that, and then I'll just bung a couple of screws in and we've got those. So onboard diagnostic cable set. What channel else, where else could you go to see such amazing content? I don't have an answer for you. So I hope that's been of some use to you, or you've been lulled nicely to sleep by my voice. As ever, thank you for watching. Alright, I decided to hook up the grounds because I always figure they're easy enough to remove later. And on the OBD ports there on pins 4 and 5, and actually these are joined together. Actually it's technically 13, 4 and 5, but I see 13 is being used by both these things, so I think I'm wrong on the 13 score. But yeah, definitely 4 and 5, and they're hooked together actually on here, so it doesn't matter which pin you use. And I'm going to use both because I have more than one wire and I'm going to need to squeeze them all in. So there, that was my final decision.